In this video, we are going to talk about tryptophan metabolism. And tryptophan is one of the essential amino acids, and it is also one of the aromatic amino acids too. So in this video, we are going to talk about the tryptophan. So before entering into the tryptophan metabolism, we have to know certain things about the tryptophan. So this tryptophan is actually an essential amino acids, and this is also an aromatic amino acid. You can see we'll be having on aromatic ring here. So this is aromatic amino acids, and another important thing is that this is a indole, it contain a indole ring. So this is a indole ring containing amino acids. And then in this entire video, we're going to talk about the metabolic pathway of the tryptophan, and also how the tryptophan can be converted into nicotinic acid, then how the serotonin melatonin is going to form and what are their roles, and we're also going to talk about the disorders that are related to the tryptophan metabolism. Yes, so these are the important topics we are going to cover in this video. And next, importantly, after completing this entire session, we will be talking about one case scenario here. So related to that of our tryptophan metabolism, we will see it later. And then we are going to begin our metabolism here. So first of all, to begin with this metabolism, what are the products that are going to come from the tryptophan is very important here. So when tryptophan is catabolized, okay, so when tryptophan is get catabolized, what are the product it is going to get produced? It is going to produce you the alanine, it is produce acetoacyl CoA and a formyl group and a niacin and a serotonin and a melatonin and the hydroxyindolacetic acid and an indigans. So like that, it is going to give 8 important products. So first of all, we are going to see all this product in this tryptophan metabolism. Okay, so you can see here, this is the tryptophan metabolism. So this tryptophan metabolism is otherwise known as kynurenine pathway. So you can see this tryptophan metabolism, it is otherwise known as a kynurenine pathway. It is very important. Why we are calling it as a kynurenine pathway? Because here you can see the tryptophan is going to form you the kynurenine here. So that's why we are going to call this as a kynurenine pathway. So we are going to talk about this metabolism. So first of all, we got our tryptophan here. So this tryptophan, it is going to convert it into N-formyl kynurenine. So this N-formyl kynurenine and further converted into kynurenine. That kynurenine is going to convert it into 3-hydroxykynurenine and 3-hydroxykynurenine into 3-hydroxyxanthralic acid. And the reaction will fall after that. So before that, we just complete this. So this tryptophan converted to N-formyl kynurenine with the help of this tryptophan pyrrolase enzymes. So this N-formyl kynurenine is further converted into a kynurenine by removing this formyl group using the THFA. So the tetrahydrofolic acid is going to get the formyl, and then they will take the formyl from the formyl kynurenine and make it as a kynurenine. So this tetrahydrofolic acid will form you the formyl THFA. So we have seen, no, so this is how it is converting the kynurenine here. And after once it converts the kynurenine, they will be further converted into 3-hydroxykynurenine. So again an important here. So they are going to convert it into 3-hydroxykynurenine. That 3-hydroxykynurenine, if it is not at all having any particular enzyme to convert into further step, they will be converted into xanthoranic acid. Then this 3-hydroxykynurenine with the help of the PLP is important, with the help of chironase enzyme. This is also another important. This 3-hydroxykynurenine, it is going to converted into 3-hydroxyxanthralinic acid. And while it is converting this 3-hydroxykynurenine, while it is converting into 3-hydroxyxanthralinic acid, they are also going to give the alanine. They are going to give the alanine out. So this alanine will be converted into glucogenic. They will be enters into the glucogenic pathway. 3-hydroxykynurenine is going to convert into 3-hydroxyxanthralinic acid. This 3-hydroxyxanthralinic acid is enter into the NAD pathway. NADP pathway is nothing but a nicotinic acid pathway. It is going to enter into nicotinic acid pathway. Okay, so tryptophan to formyl kynurenine to the kynurenine, and kynurenine to hydroxykynurenine, and hydroxykynurenine to the hydroxyxanthralinic acid. So from this 3-hydroxyxanthralinic acid, it is going to enters into the nicotinic acid cycle. That is a separate step. It is going to converted into amino carboxymuconaldehyde, and from amino carboxy one carboxy is going to remove, that's carbon dioxide remove, and that is formed with the amino muconate semialdehyde. Again there is a amine group is also removed, then it form a ketoadipic acid. From here 2 carbon dioxide is going to remove, then it forms a acetoacyl, that will enter into ketogenic cycle. So you have to keep this entire thing here. So this is all about the pathway of the tryptophan. From the tryptophan we can confer that actually tryptophan is a 11 carbon compound. Actually tryptophan is 11 carbon compound which is going to break down to give small product like this. So in the first step we have seen that there is a formation of formal kynurenine. So it is cleaved into one carbon compound. So this tryptophan is first of all cleaved into one carbon compound here, and they will also give the alanine. So you can see they will give the alanine in the step. So they give the alanine when 3-hydroxykynurenine, when it's converted into 3-hydroxyxanthrolenic acid, is going to give the alanine. So alanine is actually a 3 carbon compound. Okay, so it is actually a 3 carbon compound. So it is going to give another 3 carbon compound, and after that it finally gives an acetoacyl. You can see this is, they will be give you the acetoacyl, which is actually a 4 carbon compound. Okay, that can enter the ketogenic cycle. And remaining, okay, so remaining 3 carbon dioxide is going to removed here. So totally 11 carbon is going to cleaved in this kynurenine pathway. And we also talk about another important enzyme which I told previously, that our kynurenase enzymes. So you can see this is a kynurenase enzyme, so which is a very important enzyme that is going to work along with that of our PLP. So they will be work in relation with that of our PLP. So you can see this kynurenine, the 3-hydroxykynurenine can be converted into 3-hydroxyxanthrolenic acid. So with the help of this kynurenine enzyme, if there is no kynurenine enzyme in the sense, this 3-hydroxykynurenine will be converted into xanthronic acid that is excreted in the urine out. So this kynurenine enzyme is very important for us. So sometimes what makes this kynurenase enzyme deficiency? So sometimes this kynurenase the kynurenase enzyme, they may be deficient. So why they are deficient? Because of this PLP deficiency, because they work in association with that of a PLP. So if there is no PLP, then the kynurenase cannot able to work. That time this 3-hydroxykynurenine will be converted into xanthronic acid, which is going to excrete in urine. This indicates that there is some deficiency. There is a niacin deficiency. Niacin deficiency can lead to the pellagra. So another important term we have to know, that is a 60 milligram of tryptophan will going to give the 1 milligram of the nicotinic acid. This is also another important. So this is very important for the MCQ purpose, they may ask you. Then we talk about that the 3-hydroxyxanthrolenic acid may enters into the NAD pathway. So you will see here. So I already told us this 3-hydroxy xanthrolenic acid will enters into the NAD pathway. So we are going to talk about how the nicotinic acid is going to get formed. So that is what we are going to talk about. Okay. So here our nicotinic acid pathway. So we will be having our 3-hydroxyxanthrolenic acid, which is going to convert it into quinolinic acid. Then they are going to convert it into niacin. Then the niacin is going to convert it to NMN, nicotinin mononucleotide. So this is how the conversion will be taking place. You need not to know this enzymes at all, but similarly you just see. So the 3-hydroxyxanthronic acid will convert it to quinolinic acid. That quinolinic acid will convert it into the nicotinic acid. That nicotinic acid, okay, so that here when it's converting, this quinolinic acid is going to convert it into nicotinic acid. There will be the excretions of 1 carbon dioxide will be taking place. And also you can see this when this niacin is formed, which is going to convert it into that niacin mononucleotide using an enzyme called as guanylynated phosphoribosyl transferase. Guanylynated phosphoribosyl transferase. So this is one of the enzyme, guanylynated phosphoribosyl transferase, which is going to convert it into a nicotinin mononucleotide. Okay, so then this nicotinic mononucleotide, what is going to happen? This nicotinic mononucleotide, the main aim is going to form you the NAD. They have to enter into the NAD pathway. So this is going to convert it into desamido NAD plus. So using one ATP is going to hydrolyze in this step. Then this desamido NAD plus will further convert it into that of NAD, nicotinamide adenine dinucleotide. This mononucleotide can be converted into dinucleotide. In the intermediate step is going to be desamido NADP, from where there is one ATP is going to hydrolyze. Here also one ATP is hydrolyzed, and the glutamine is going to convert to glutamic acid. There is no enzymes, more enzymes you can see in this entire pathway. We can see only the guanylynated phosphoribosyl transferase, one enzyme we can see here. So this is the nicotinic acid pathway. Okay. So from this 3-hydroxyxanthonic acid, one NAD plus is going to get produced, and there is also intermediates like from the guanylinate, from the niacin, and then from the nicotine mononucleotide, and from the desamido, then nicotinic adenine dinucleotide. This is how the nicotinic acid pathway will be there. Another important product from the tryptophan is the serotonin. Let's see how the serotonin is formed from the tryptophan. Okay, so here you can see here we got our tryptophan. Okay, here we got the tryptophan. That tryptophan you can very well learn in the vitamin classes at all. The tryptophan can be converted into 5-hydroxytryptophan, which is further converted to 5-hydroxytryptamine, that is forms you the serotonin. So the tryptophan, while it is converting into the 5-hydroxytryptophan, so they will be having the enzymes called as tryptophan hydroxylase enzymes. So you should see that they contain a tryptophan hydroxylase enzyme is a very important enzyme, and there is also further substeps will be taking place, like dihydrobiopteron is going to convert to tetrahydrobiopteron, and NADPH also get produced here. This 5-hydroxytryptophan, with the help of the PLP dependent aromatic amino acid decarboxylase, one carbon dioxide is going to move out, that is going to convert it into 5-hydroxytryptamine, that is what you call as serotonin. Actually, what is a serotonin? Serotonin is actually a neurotransmitter. So this is a neurotransmitter, and this when the serotonin level is lower, that can lead to the psychosis. Then there also lead to argentophenoma, that is one of the carcinoid tumor. They also attack our small intestine and appendix. So this tryptophan can be converted into serotonin. If there is any niacin deficiency also, it cannot able to convert this tryptophan into serotonin on that time. So urine will excrete more amount of the 5-hydroxyindole acid. Okay, that amount is also going to be increased in the urine. Okay, so this is a serotonin. And what is 5-hydroxyindole acid is that when we have our serotonin, the serotonin is going to form the melatonin. From the serotonin only melatonin will form. Okay, the serotonin will be converted into acetyl serotonin with the help of acetylase enzyme, and now there is a methyl group is transferred that forms the melatonin. So this is how the reaction will be taking place. But sometimes if there is no serotonin, if there is serotonin cannot able to convert it into melatonin, that time they will be enters into the hydroxyindole acetic acid production using the enzyme called as monoamino oxidase, so that they will be excreted in the urine very clearly. You can see that is going to excreted in our urine. Okay, so then this is the excretions of the hydroxyindole acetic acid. Okay, so this is what they have mentioned. Urine is going to excretion is increased when the serotonin level is generally get lowered. Okay, so in case of any niacin deficiency also, we can see there is more secretion of this. Okay, so then you have talked about how the melatonin has come. Melatonin is also produced by the pineal gland. So we can very well appreciate in the sleep and wake cycle, biological rhythm, biological clock, diurnal variation, like that. So it is also one of the neurotransmitter. It is going to produce from the serotonin using acetylase, acetyl serotonin using a methyltransferase, melatonin. This is how the melatonin will be produced. And we also talk about two excretory products. One is going to be our hydroxyindole acetic acid, one of the excretory product here. Another excretory product is our indican. How the indican is produced? So we got our tryptophan here. So that tryptophan is going to produce a indole pyruvic acid, indole acetic acid, one carbon dioxide going to removed from the pyruvic, that forms the acetic, indole acetic acid. One carbon dioxide move from the skatole, again one carbon dioxide remove from indole. Now the oxygen added from the indole. Okay, skatole will remove the carbon dioxide, forms the indole. Now the oxygen added, they form the indoxyl. That indoxyl, again one sulfur is added, they form the indoxyl sulfate. Okay, they form the indoxyl sulfate here. Okay, so that indoxyl sulfate will lead to that of indican. So this is how the indican is going to produce. And now we will talk with the tryptophan disease. Is very important disease called Hartnup disease. Okay, so this is a Hartnup disease. It is autosomal recessive disorder in which the GIT will mal absorb. They cannot able to observe the aromatic amino acid. Even kidney cannot able to observe this aromatic amino acid. So that can lead to the tryptophan deficiency in our body. So there is a tryptophan deficiency, niacin deficiency, pellagra will be there, and that can lead to the dermatitis like that. So we are going to treat it by using a high protein diet in our food, and also we are going to administer the niacin here. So then we'll end up with this. We'll have this total summary of this metabolism, like how tryptophan can be converted to N-formyl kynurenine and formyl tetrahydrofolic acid. They form the one carbon compound. Sometimes this kynurenine may enter into the reaction, like forming hydroxykynurenine, that is form you alanine, that enter glucogenic, that form acetoside enters into ketogenic. Sometimes they enter into nicotinic acid pathway. The tryptophan forms a serotonin. From the serotonin we got a melatonin. Sometimes they form a indicans. Sometimes they form a 5-hydroxyindole acetic acid. Like that their excreted products will be formed. These are the entire pathways, and these are the important questions regarding this tryptophan metabolism.